Hi, and welcome to this video on thunderstorms. And specifically, we are going to talk about thunderstorm avoidance. Now, a thunderstorm avoidance occurs in many different phases during flight. Probably the most important is pre-flight. This is where you're trying to estimate or figure out your route of flight and how to circumnavigate thunderstorms. But also it can happen while you're airborne. And then in later videos, we'll talk about rules of thumb for avoiding thunderstorms and what to do if you inadvertently encounter a thunderstorm. So during the pre-flight, typically what you're trying to do is get the big picture. You're not really tactically thinking about flying in between storms or around storms. You're looking at the big picture. So that means that you should pretty much have an idea of the weather systems that are occurring. Where's the highs, the lows, where's the ridges, troughs, cold fronts, warm fronts, and then from that, try and superimpose upon that, the thunderstorms, where they're going to occur, where have they been occurring, where they are currently occurring, and what is the forecast. So you may need to make use of all available resources. And one of the best resources for thunderstorm planning is the Aviation Weather Center. The Aviation Weather Center has a specific location where you can find thunderstorms. It's called Convection. It's under the Forecast tab. So go to the Forecast tab and then go down the menu and you'll find the first item is Convection.
Under the Convection tab are 7 sections. When you get to that page, the largest image is the WST, which is convective segments. Those are the active convective segments at that time. The TCF, or the Traffic Flow Management Convective Forecast, is the next one down on the side. The Extended Convective Forecast product is to the right of that. And then the last 2 images on the bottom are the Storm Prediction Center watch and warnings, which ones are active at that time, and then also the convective outlook for severe weather. And there are smaller little items or buttons at the bottom that can be clicked to show the current radar, and then also the center weather advisory or meteorological impact statements for that area, for the U.S.
What the TCF is the Traffic Flow Management Convective Forecast. And this is a forecast of high confidence. When they say high confidence, they mean more than 50% chance of it occurring. So it's a high confidence graphical representation of where they expect convection to be, or thunderstorms. So they give you the coverage, also they give you the intensity, and finally they give you the tops of the storms. And this replaces the old CCFP, which is the Collaborative Convective Forecast product, which was used for many years. And what this is, basically, it's graphics showing you where there's thunderstorms and where they're going to form and the coverage of the thunderstorms. This forecast is made every 2 hours. It's issued or comes out 30 minutes prior to its issuance time. These forecasts are made around the clock every 2 hours, 7 days a week, 24 hours a day. And the forecasts go out to 4, 6, and 8 hour forecasts into the future. So there are certain criteria for areas and for lines of thunderstorms that they forecast. They don't forecast every individual thunderstorm, but more or less areas and lines. The areas have certain criteria. They have to be pretty strong, 40 dBz or stronger. The tops have to be up to about 25,000 feet. Less than that, typically they're just rain showers, so 25,000 feet is kind of the cutoff. They have to cover 25% of a polygon area, so in other words, has to be kind of a bigger area. And as we mentioned before, the forecaster's confidence has to be 50% or greater, thinking that those will happen. As far as lines, once again, more details, but the reflectivity of the line has to be more than 50 dBz. Length has to be 100 nautical miles. Linear coverage of at least 40%. In other words, along a line, you may have gaps, but you have to have more than half of that line covered with storms. Echo tops up to 25,000 feet. Once again, also forecaster confidence of 50% or greater, a high confidence going to happen. So the TCF is available March 1st through October 31st. It's collaboratively produced by several different entities. The Aviation Weather Center, located in Kansas City, Missouri, the ATSC, the Command Center, National Aviation Meteorologists, they're located in Virginia, outside of the Beltway. And then, of course, all the CWSUs get together, and then also the airline meteorology departments get together and their dispatchers. And they all collaboratively determine where there's going to be thunderstorms. The purpose of this is so that there's safe and efficient use of the National Airspace System. So it helps air traffic managers make decisions to anticipate where there's going to be storms, and everybody works together collaboratively to figure out the routes that aircraft are going to take in the event that thunderstorms block certain routes. As you know, there's a lot of air traffic on the East Coast of the United States. If there are thunderstorms, for example, between Chicago and Cleveland, there's a line of storms, then that affects quite a bit of air traffic because a lot of air traffic flows between Chicago, New York, Chicago, Boston, Chicago, Washington. So if you have that problem, they've got to reroute the aircraft. So they try and anticipate that and figure out what routes the aircraft are going to take, those airliners are going to take. So here are the more specific purposes of the TCF. It provides accurate representation of the convection of most significance for strategic decisions of the traffic management people. Provides a common forecast, everybody working together, the airlines, the FAA, the Center Weather Service units, and people like that all looking at this and trying to figure out the best plan of action, the best game plan when thunderstorms occur over a region. And it is the TCF is the source, the main source that they use for determining all these plans. It is the authoritative source for convective forecasts. So it's designed for mostly people who are making decisions about traffic, where air traffic goes, and when to launch aircraft, or when to hold them at the gate. So this includes the command center in Virginia, also the individual centers, the traffic management units of each center. For example, at Minneapolis, they have a traffic management unit that determines how much air traffic they can handle going into Minneapolis hubs and also Minneapolis airspace. And then finally also the flight ops centers of the airlines, so that they know if there's going to be delays, and based on that they can either postpone flights or cancel flights. So this is what the product looks like. It's basically areas and lines of thunderstorms. Areas are outlined in blue and lines are lines of purple. And then for areas, they shade the area based upon how much coverage in that area they think there's going to be thunderstorms. If you get the kind of very thin dashed lines going through that, the shading, that shows that it's a broken hatching, which means sparse coverage. 25 to 39% of that area is covered with storms. But if you have striped hatching, which is more closely spaced lines, and they're solid lines, that means that you have medium coverage, which means between 40 to 74% of that area is covered with thunderstorms. So there's more storms across that region. They also put the tops, and they don't give you an exact height, they just give you a range of heights. For example, if you see 340, that tells you the storms are going to be between 30,000 and 34,000 feet. So those are the different altitudes and the different ranges. These are, the TCF has a key, so it's you don't have to memorize all this stuff. Usually you just look at the key and it tells you what's going on. As far as lines, they either use a solid line or a dash line. A dash line means medium coverage, which is between 40 to 74%, or broken coverage. And then if there is high coverage that is solid, you'll get a solid line between 75 and 100% of that line covered with storms.
Another product that's available at the Aviation Weather Center is the Extended Convective Forecast Plot, or the ECFP. And the ECFP is very similar to the TCF in the respect that it gives you probabilities of thunderstorms. However, the TCF only goes out 8 hours into the future, whereas the ECFP, as the name implies, it's an extended forecast, and this goes out to 72 hours. The ECFP should be used as a planning tool. In other words, people that are dealing with air traffic, in other words, the airlines, meteorologists, and also air traffic control are all looking at this product, and it gives them an idea over the next couple of days where to expect thunderstorms. Unlike the TCF was a collaborative product, meaning that it was generated by a number of people. A lot of people had input. The ECFP is totally automated, meaning that a computer model generates it. And specifically, the computer model is an ensemble or a SREF product that gives you probability of thunderstorms across certain regions. Here's an example of the ECFP for a particular day this summer, and it shows the 3 different probabilities of thunderstorms or convection. And the probabilities go from 30 to 49%, from 50 to 69%, and then the blue areas, the filled in blue areas, are more than 70% probability that thunderstorms will occur over those regions. On this diagram, you can see that it only goes up to, on this particular day, the 2nd probability over Colorado. So this is a good product for looking at thunderstorms over the next 3 days. Those are some weather products that you can use during your pre-flight if you are concerned about thunderstorms and convection.